In this video, I'm going to explain a few questions on using log rules. So the first question is when you have log 6 to the base 2 plus log 2 to the base 2, and then we use the logarithmic law log x plus log y, which is equal to log xy. So you simply have to do is 6 times 2, and the log 6 times 2 to the base 2, and log 6 times 2 is 12. So the final answer is log 12 to the base 2. The next example is with log 24 minus log 8. So you will use the rule log x minus log y, which is equal to log x over y. So which means this is going to be log 24 over 8, which is log 3. The next one is 2 log 4 to the base 3 minus 3 log to the base 3. And now we are using the law a log b, which is same as log b to the base a. So then you will have, first you need to, before you start applying any log rules, you have to make sure that there is nothing in front of log. So you need to get rid of this 2 and 3 using this law. So this becomes log 3, 4 to the power of 2, and log 3, 2 to the power of 3. 4 to the power of 2 is 16, 2 to the power of 3 is 8. So you got log 16 to the power to the base 3 minus log 8 to the base 3. And then we'll use the same formula log x minus log y, which is equal to log x over y. So this is equal to log 16 over 8 to the base 3, log 2 to the base 3. The next example is when the log a is 0.25, log b is 1.3, and log c is 0.6. So these values are given, and you have to find the value of log b divided by ac without using a calculator. So again, we know that if we are dividing two things using log, the formula is log x over y is equal to log x minus log y. So which means this is our x, and this one is our y. So we will get here log b minus log ac, and then log b, log ac is again is the product of two things, and we know the law for product is log xy is same as log x plus log y. Then you will open this log a plus log c, and now we have negative in front of the bracket, so you open it. Log b minus log a, when you open it, this sign will change into negative. And then log b, the value is 1.3, log a is 0.25, and log c is equal to 0.6. And then when you do these calculations, the answer is 0.45. The next one is again using the log rules. So we know for plus, it's the number here will get multiplied. So 6 times 3 is 18, base is 8. So log 18 to the base a. Here we have subtraction. So log 9 to the base 5 minus log 3 to the base 5. 9 and 3 will get divided. So 9 over 3. And then you have log 9 over 3 to the base 5, which is log 3 to the base 5. Then this one log 6 to the base 7 and minus 1. So this seems like a bit difficult. But what you need to do here is you need to change this 1 into whatever base is given to you. So we know that log a to the base a is 1, which means I can rewrite log 1 as log 7 to the base 7. So then you will have same basis, because any rule you can use for log, the basis has to be same. So now you have 7 here as a base, 7 here as a base, and we know for subtraction it's 6 divided by 7. So this is your final answer here. Similarly, in this question, you will use different laws first. So first thing, before you use any law, you have to get rid of, as I said before, anything which is in front of log. So this 2 will be log 5 to the power of 2 to the base 10. Again, using a log b is equal to log b to the power of a. Now, if nothing is written, means the base is 10 here. But this is true for any base. And now we need to change this 2. So now I know the base is 10. So I'm going to rewrite this 2 as log 100 to the base 10. We know log 100 to the base 10 is same as log 10 to the power of 2 base 10. And now this one is 1. Or this 2 will come in front, and we know log 10 to the base 10 is 1. Using the same rule here. So which means we got this as log 25 to the base 10 plus log 100 to the base 10. And now for plus, we multiply these numbers. So this will be log 2500 to the base 10. The next example is the value of x and y is given. X is log 2 and y is log 6, and you have to write these expressions in terms of x and y. So we know log 12, so you have to make sure that you rewrite this number using the numbers which is given, which is in this case is 2 and 6. So log 12 is 2 times 6, and now we can apply the log rule. So this is log 2 plus log 6. Log 2 is x, log 6 is y, so this is x plus y. Similarly, log 3, 6 over 2 is 3. So which means log 6 minus log 2. Log 6 is y and log 2 is your x. So which means the final answer is going to be y minus x. Now log 48 cannot be written entirely in terms of 6 and 2. So what we did here is this is 8 times 6, and 8 can be written as 2 to the power of 3. And 6, we don't have to do anything with 6. And now I can use the log rules. So this is log 2 to the power of 3 plus log 6. And this is same as 3 log 2 plus log 6. So we got this equal to 3x plus y. So this is your final answer for log 48. Similarly, now we have x is equal to log p to the base 3 and y is equal to log q to the base 3. And z is log r to the base 3. And you have to write log pq over r to the base 3 in terms of x, y, z, and log p square r over q cube to the base 3 also in terms of pq, in terms of x, y, and z. So let's have a look. So here, when you have log pq over r to the base 3, we will first use again x over y. So it doesn't matter if you have in the numerator the product of two numbers, you just need to follow the steps, so don't rush. So first thing you do is first you use the rule for division. So we got log pq to the base 3 minus log r to the base 3, and now you use the rule for the product, which is log p to the base 3 and then log q to the base 3. Now we know this is x, this is y, and this is z. So the final answer is going to be x plus y minus z. Similarly here, so first you start with p, whatever is in the numerator, denominator doesn't matter. First you have to identify, the first step is to use the law for division, which is log of numerator minus log of denominator. Now we need to, again, steps are very, very important. Don't rush it. So now we need to use the rule for the product here. So this is p square, this is q, and here we are using again log a to the power of m is same as m log a. M, it doesn't matter. You can use any letters here. So this one is 3 log q to the base 3, and then this one again using this law is 2 log p to the base 3. Now we know log p is x, log r is z, and log q is y. So 2x plus z minus z or z minus 3y is your final answer. Now the next one is finding the exact values, which means if they ask you find the exact value means you cannot use. Exact value means you can't use calculator. Okay? So you can't use your GTC. This is without calculator. So when you have ln e square, this is same as, now again I'm using the law ln a to the power of m, which is m ln a. So this 2 will come in front, and we know ln e is 1, something which you should remember. So the answer is 2. Now the next one is e to the power of ln 5. So we have another rule, which is e to the power of ln x is equal to x. So this means e and ln will get cancelled. The final answer is 5. E is the natural log. Okay. Now here ln e x over e y. So we use the same. So this, now we know ln x over y is equal to ln x minus y. So we use the same thing here. So here we got ln. But before we do that, actually here this is e to the power of x over e to the power of y. When the bases are same, we know that we can subtract the exponent. So this is x minus y. And then we didn't use any rule here. It's just simplifying when you have when you are dividing two exponents with the same base. So here you have x minus y, again using this law ln am, and ln e is 1, so you got x minus y here. So this one we have to find the value of log 20 to the base 3 to 3 significant figures. For significant figures, we can also use the short notation SF by converting to the base 10 and by converting this same thing to the base E. So if you remember the base rule, you can convert any base to any number. So what I'm doing here, because we want base 10, it's given in the question. So we are rewriting this as log 20 divided by log 3. If nothing is written, which means the base is 10, which is also called common log. Okay, so we do not write here 10. So it's understood if we just write log 20, this is same as log 1020, but we never write in this form. And base 10 is called common log. And if you use your calculator, you will find the answer was 2.7268333028, since they ask us to round it to 3 significant figures. So which means we need to look at this one, and this number is greater than equal to 5, then we add 1 to this one. So we got 2.73. Now we are going to do the same thing with change of base as E. So this is same as log 20 to the base E, log 3 to the base E. Again, you would never write, whenever you have a base E, you never write in this form. It's always ln 20 and ln 3. So when you have log x to the base E, the notation which we use, the proper notation which we use is ln x. So you will never see this notation. So this is ln 20 over ln 3. And when you use your GTC and round the answer to 3 significant figures, you again got the same answer, which is 2.73, which means it doesn't matter when you are evaluating any value for log with any base, and if you change it to any base, base 10, base E, base 2, any other base, the answer will remain same. So that is called the change of base rule. Okay, so the next one is also on change of base rule. So when you have log 7 to the base 4 as P and log 9 to the base 4 as Q, and they are asking us to find log 9 to the base 7. So clearly the values which was given to us was with base 4. So which means the indication is that I have to change. If I want to find the value of log 9 to the base 7, I will have to change this into base 4. So now we know this is P and Q. So changing this into base 4 will be log 9 to the base 4 and log 7 to the base 4. And we know this value is Q and the denominator is P. So the final answer is Q over P. So the change of base rule is when you have log x to the base A, log x, and then whatever is A goes in the denominator, log A, and then you can have any base here. Remember, A, B, and X has to be positive here. So that's it for today's video. Thank you.